Hi everyone, my name is Patricia. I'm a PhD student at the Federal University of Amazonas, and today I'm presenting the paper Buying Time in Software Development, How Estimates Become Commitments. This paper is co-authored by Professor Igor Steinmacher from UTF-PR, Professor Bruno Gadelha, and Professor Tayana Conti from the Federal University of Amazonas. In this paper, we explored the question of how are software estimates used to establish software development commitments. And we were interested in this because in real life, people may mix the concept of an estimate with other related ones like targets, which are just desirable business outcomes. And we approached this research question using a method based on a mix of observation sessions and interviews, at first in one company, and then we moved to interviewing people in other companies to understand more of our results in this context as well. And the major first finding we had was related to defensible estimates. So we had a situation where people were estimating in groups during estimation sessions, and each estimator had to provide his individual estimate, and later on the team had to decide on the internal estimate for the task they were working on. And after the estimation session, sometimes the team leader or the manager just changed this internal estimate a little bit to form a final value, which was used to establish a commitment. And of course that during the estimation session, disagreements occurred. And the team had to engage on a disagreement resolution strategy, such as averaging the individual estimates or picking the highest value. But the strategy that really caught our eye was changing the individual estimates. So we saw that happening in observation sessions such as this one, where the software developers, which are not in this figure, had already provided their estimates, and then the software tester, this guy here, provided his estimates, and then when the team leader was totalizing the estimates, she started to think aloud, saying things like, well, I don't know whether I can defend 9 days. And then the software tester immediately changed his estimate to make the final one defensible. So changes in estimates due to management pressure or organizational agendas were already reported in a previous study in the literature. And our results reinforce the needs that we have as technical staff to learn skills to convince others of our estimates instead of just changing it. We need to learn how to defend these estimates when we really believe in them. And the second major finding we had regards padding. So we found evidence of different padding scenarios, such as when the estimator embeds padding in his or her individual estimates, or when the team leader adds padding to the internal estimate and before establishing a commitment, or when no padding at all is possible. And you can find more about these padding scenarios in the paper. Today we're focusing on the reasons to pad. The first major reason to pad is for getting a contingency buffer, like in this task here, where the commitment for it is the estimate plus padding for dealing with risks that may occur. And we have the software developer talking about this in here. So she said, well, we pad because we are afraid of the problems we will have to face, like when we're working on larger tasks. The second reason to pad is for completing other tasks. So this connects with the scenario where no padding at all was possible for a previous task like task B. So when we are estimating other tasks like task C, we provide, when we are committing to task C, we actually provide the estimate for task C plus some padding for improving, for instance, the previous version of task B. We have this team leader talking about it here. He was saying that, well, we gave an estimate of 30 working days for functionality Y, but we are counting on the padding of other tasks to finish it. And the third reason to pad is for improving overall quality. So we have this task D here, where the commitment for it is the estimate plus some padding for correcting a known bug in production, but it can be for improving our tests, for instance. And we have this team leader talking about it here. So he said, well, we also pad when there are errors we know, and we add one day in one task to correct it. So this idea of padding for contingency buffer is actually a recommendation from PMBOK, for instance, but padding for completing other tasks and improving overall quality is less explored in literature. There is a previous study about it, but that's pretty much it. And we realized it was a way, a managerial path for technical debt repayment. So while researchers are focusing on understanding how to repay technical debt from a technical perspective, in real life, people need to find a space in their schedule to allow for it. And these uses of padding, these different reasons to pad, are actually ways to buy time for balancing short and long-term needs in software development. So sometimes we cannot pad, but then we pad later to compensate for that. So wrapping up, how are software estimates used to establish software development commitments? Well, sometimes people change their estimates, so we need to learn how to defend those estimates instead of just changing them. And padding is actually a tool in the software engineer's toolbox for dealing with human and social aspects of software estimation, allowing us to balance short and long-term needs in software development. And that's it. Thank you very much.
Hi everybody, I'm Rafael de Mello from Cefet, Rio de Janeiro, Brazil. I'm here to briefly introduce our research on the theory of social representations for investigating confusing code, to be presented at this edition of Chase. This work results from a collaboration with researchers from several Brazilian institutions. Our research is supported by the Brazilian National Council for Scientific and Technological Development. Have you ever heard about the theory of social representations? No? So I think you would like to know that this theory fits well to support exploratory research in several fields highly influenced by social aspects, such as software engineering. Investigating social representations in our field may be considered an innovation. Indeed, we reported a very first experience on applying the theory of social representations in software engineering 2 years ago at the 12th edition of Chase. The theory of social representations comes from the social psychology. It refers on how a particular community collectively elaborates some object, socialized among its members. By collective elaboration, we mean the knowledge unconsciously shared among the community members, which goes beyond individual opinions and formal knowledge. Among others, this elaboration is composed of hidden but core issues and maybe preconceptions. Consequently, we may say that social representations influence how individuals behave and communicate in their communities. Now, let us suppose that developers from a particular company share a strong belief that novice developers tend to produce confusing code. This preconception will influence how the members of this community deal with code reviews. For instance, it could lead to a more laborious approach for reviewing code implemented by novices. This preconception may also lead reviewers to feel less motivated for reviewing code made by novices. In our paper, we report an investigation on the social representations of confusing code by software developers. For supporting this investigation, our study involved 2 Brazilian communities. The first community is the PUC Rio Science Park. This community conducts several research and innovation projects. The second community is EDGE, a center of software development and innovation located at Maceió. This center has a strong connection to the local industry. Among others, these communities differ in their project domains, main customers, and backgrounds. Despite these differences, our investigations revealed relevant commonalities among their social representations of confusing code. From these findings, we depicted a set of core issues of confusing code that potentially goes beyond the walls of particular communities. This set includes technical and non-technical issues. In this video, I would like to talk about two core issues of confusing code we found. The first one is the belief that authors of confusing code have a lack of commitment. Developers from both communities employ the pejorative adjectives such as sloppy, lazy, procrastination, and lack of professionalism when referring to the work performed by the authors of confusing code. Besides, the analysis of the arguments given by developers suggests they blame some colleagues. The second core issue addresses bad feelings, a side effect of confusing code. Among the bad feelings reported, developers evoked sensations of frustration, discouragement, sadness, and disgrace. A deeper analysis of the terms evoked and the arguments given led us to conclude that the associations to lack of commitment and bad feelings are directly connected, representing two sides of the same coin. These negative beliefs and sensations, having individuals in the center, indicate that confusing code may be a recurrent source of veiled dissatisfaction and even internal conflicts. In our paper, we also discuss alternatives for overcoming the core issues of confusing code. To combat the preconceptions and bad feelings surrounding confusing code, we propose teams adopting agile values of courage and feedback, followed by the agile practice of pair programming and DAO meetings. DAO meetings contribute to inhibiting procrastination. Also, developers should continuously report their progress. Besides, developers challenged by certain programming tasks are stimulated to expose them to the team. This behavior may lead to a spontaneous collaboration from colleagues. Pair programming stimulates developers to continuously work collaboratively, alternating between the role of reviewers and authors of the source code. Consequently, this practice may lead developers to think twice before judging colleagues. Besides, it stimulates the continuous verification of the source code, mitigating bigger problems. So, interested in more results and discussing our findings? You are welcome to join in our presentation session at Chase. Let's keep in touch. Abraço from Brazil.
Hi everyone, I'm Sávio Freire, a PhD student at the Federal University of Bahia in Brazil, and a researcher in the Technical Data Research team. Today I present the paper How Experience Impacts Practitioner Perception of Cause and Effects of Technical Debt. This work was done by me, along with the other research of Technical Data Research team. This work in the context of technical debt, TD. TD is a term that describes the effects of incomplete tasks or artifacts in software project. These effects can bring benefits like high productivity or harmful, for example, make it difficult the software evolution. Software development is a social and knowledge-intensive task, and human-centered factors have been found to affect software projects. Development teams whose members have heterogeneous experience levels tend to have better performance because the diversity of experience facilitates information exchange and communication due to different viewpoints. The goal of the work is to investigate the impact of the experience level on how practitioners perceive the most likely causes that lead to TD and the effects of TD that have the highest impacts on software projects. For achieving the goal, we used data collected by the InsightTD project. This project is a globally distributed family of industrial surveys composed of 28 questions. The goal of the project is to organize an open and generalizable set of empirical data on the state of practice and industrial trends in the TD area. In the survey, the respondents indicated the country, system size and age, team size, company size, process model, role, and the level of experience in this role, low, high. Also, they cited 5 causes of TD ordered by the likelihood of causing TD and 5 effects of TD ordered by the level of impact. For analyzing the responses, we performed different data analysis strategies. In characterization questions, we calculated the quantity of respondents choosing an option. In questions on cause and effect, we first applied open manual coding to identify cause and effects. After, we calculated the cause and effect exposure, taking into consideration the cause and effect likelihood and the impact level of that cause and effect. Then, we produced the ranked list of cause based on cause exposure and effects based on effect exposure for low and high experienced practitioners. Finally, we calculated the rank-based overlap that measures how similar ranked lists are. Results: we analyzed 227 responses collected from 6 countries. We seek to answer the following research question. Are the causes most likely to lead to TD perceived differently by low and high experienced practitioners? We identified 47 causes reported by low and high experienced practitioners, such as deadline and appropriate planning. Other 24 causes were only reported by high experienced practitioners, for example, adoption of control solutions definitive and external component dependency. Only 5 causes are reported by low experienced practitioners, such as custom don't listen to product team, lack of change control, and lack of information. Here we present the result from the RBU analysis. We can see that the similarity level is about from 80 to 90% between the two lists. It indicated that the perception of causes by low and high experienced practitioners is quite similar. Here we have the comparison between the top 10 most cited causes by level of experience. We notice that the lines follow a uniform trend with few crossings between them. Although practitioners from both lists perceive the cause very similarly, there are some small differences. Now investigating the effects of TD. Are the effects of TD that have a bigger impact on software projects perceived differently by low and high experienced practitioners? We identified 53 effects reported by low and high experienced practitioners, such as delivery delay, low maintainability, and financial loss. 9 effects were only cited by high experienced practitioners, for example, increased in risk, lack of training, and legal issues due to non-compliance with contracts. And 6 effects were only cited by low experienced practitioners, for instance, architectural issues, constant need of retest, and lack of commitment of users. Now we present the results from RBO analysis for effects of TD. We can see that there is a considerable difference of perception on how low and high experienced practitioners see the most impactful effects of TD. Here we have the comparison between the top 10 most cited effects by level of experience. We observe many crosses between the lines in the graph, indicating different perception of the practitioners. To make our results more feasible for use in practice, we organized them into a heat map. The map shows the difference between the perception of low and high experienced practitioners. For example, a high experienced practitioner could notice that maybe they should consider that lack of experience can be a source of TD. Final remarks. This study investigates if the perception of cause and effects of TD is impacted by the practitioner's level of experience. The next steps of this study include increase the external validity, to include more data from other inside-the applications, and performance interviews with low and high experienced practitioners to triangulate the obtained results to one report in this study. Thank you.
Hi, I'm César França from the Universidade Federal Rural de Pernambuco in Brazil, and I'm presenting a literature review on gamification in software engineering, carried out in partnership with Carlos Barreto. Gamification has emerged as a very promising and popular strategy to enhance engagement and motivation in industry. You may have even spent many hours of your life gaming, but gamification is not gaming, and it's not a very straightforward concept either. We decided to carry out this literature review to check out how gamification has been investigated in practice in software development industry and what we have learned so far. We started our study with an ad hoc review, then we conducted a more systematic search and complemented it with a backwards snowball search. We put as much detail as possible in the text, but it's a short paper, so some important detail may be missing there. It's also important to say here that we were interested in industrial experience, so educational accounts were all removed from our analysis. In the end, we skimmed over about 400 papers and selected 130 papers to analyze. Okay, what have we discovered then? First, 30% of the studies just assume that the readers know what gamification is and do not offer any definition for gamification, which shows a clear lack of theoretical caution in this area. Even among the majority that refer to gamification as the use of game elements in software development, the term game elements appears sometimes as game metaphors, game mechanics, game dynamics, game thinking, games, and several other labels. And we are pretty sure that they are not talking about the same things. We also mapped the most common game elements being investigated, which are points, badges, and rankings, as expected. In the most popular process areas under study, which are software construction, requirements, and management, which just follow the same trends of previous studies. Finally, an impressive number of 70% of the papers do not report any practical influence of gamification in software engineering. There is actually some very interesting evidence showing that it can enhance collaboration, motivation, product quality, but there is also very compelling evidence showing irrelevant benefits or even negative effects. So, unfortunately, there is not much we can say about the effects of gamification in software engineering. But it's a short paper indeed, and there is still a road of data ahead for us to analyze. What we can say is that it's past time for gamification research to improve. In the near future, we would like to know more about what works, where, how, for how long, and why. And we think that you probably would like to see that too, right? Thank you.